Hey, everybody. Hi. So what I'm here to talk about is the way we interact with all technology that we use. It's about to change, and in a very big way. So to first understand how it's going to change, let's look at how it's already changed. First, we were writing words to interact with computers. In the very beginning, it was in assembly languages and in coding, essentially, and later we figured out that we could write in English to play games or talk to our computers in that way. And then we invented mice, and a whole new set of gestures became available to us. All of a sudden, we were able to click to select what we want to look at, or scroll through a page that we want to browse, or drag. And while these gestures seem really intuitive and natural to us, at the time, they had to be learned. Later on, we have a touch screen, and all of a sudden there's a whole new set of gestures that a lot of us had to learn. So pinching to zoom, swiping to unlock or delete something, and you can even swipe to get a dinner date if you want. Shaking, using the phone's sensors to either browse for WeChat contacts, or in this case, turn off an alarm is another gesture. And while a lot of us had to learn these, to the next generation, and research proves this is now an intuitive part of communication and development of language. So it's all about to change. Because from the first languages to graphical user interfaces, to more advanced, all the way to touch screens, and actually the screen you're looking at even now, it all is based off of a 2D plane, right? It doesn't matter if you're touching or dragging on a mouse or writing, everything you're doing is in 2 dimensions. So what happens when we are able to take technology and we're not in 2 dimensions anymore? And it's not going to look like this. I actually just added in this slide now. A lot of people, when we talk about future interfaces and augmented reality, they assume Google Glass. But let's really look at what this is. It's a great product. It brought the conversation forward. But all this is a 2-dimensional screen that's now closer to your face. It's not going to look like this. The future is going to look a lot closer to this. Actual computation that integrates with your lifestyle in the 3D world. So your weather app is no longer just a 2D screen. Your weather app is something that can live on your kitchen counter. Your soccer game, you don't need a TV anymore, because now you can put a 2D plane that plays video anywhere in your life. If you want recipes, just put it on your kitchen countertop or your cabinet. So we're no longer constrained by having to design everything for XY space, but all of a sudden we can have a Z axis. And we can have our digital objects in line with the physical objects that we already use every day. So very rapidly, and I suspect in the next 2 years, we're going to be able to take everything that we already do and move it into this real world. So this is actually already a working email demo by Magic Leap, and when this person wants to check their Gmail, there's all of a sudden an object in front of them that they're able to interact with. Okay, so you're able to actually check your email in real space. So you no longer have to have a computer screen at your desk. You can just bring these objects. If you want to watch a video, you bring that object into your real world space. So we're interacting with our computer in the same way that we're currently interacting with real world objects. And this is very, very close to being possible. So what I want to talk about what not to do is something like this. This is a screenshot from the Avengers. And as you can see, it's this very cool, futuristic interface. But everything in front of her is just a 2D screen. So what's really the point of this if all we're doing is taking existing computer screens and, well, you don't have to use a monitor anymore, but it sits right here in 2 dimensions. I think this is a really weak example of what good augmented reality will look like. So there are many cool examples with that. For instance, you could use your tablet to look at an advertisement, or navigate through using your smartphone or glasses, and it overlays with the real world. And Ms. Young eloquently gave many examples of augmented reality that would function in this fashion. But while these examples are undoubtedly cool, things like this and Pokemon Go are wasting a ton of potential in building something that could actually interact with, or we could interact with in our lives, just as we interact with real objects. Using something like this, it doesn't actually change the apps we're using, it just changes the format that we view it on, right? So there's no sense in putting on a headset if you're going to be using the same content that you'd view on your smartphone or on your computer anyway. But when we actually are moving computers into 3D space, everything changes. We don't have to be limited by this 2D world anymore. So this is an Excel spreadsheet. And everyone should be familiar with this. There's an X and a Y, or X and a Y. And I just took this image before. This is the future of Excel. So it's a 2D screen that sits in my real world that I can walk around, and it lives on my desk, and you can use it. But why do we need to be constrained by X and Y? Why can't an Excel spreadsheet look like this? Why can't this cube of data live in the real world? Why can't newspapers, so this is a news website, and it looks about the same as a newspaper from 100 years ago, but why can't we tell stories and experience the news in 3D space? Why can't a news anchor come into our home, sit down, and explain to us the day's current events? And they can, but we have to build it. So the way that I tackled this problem is with my own company called Mediviz. And surgeons and other doctors are dealing with a huge problem, which is this is how they're viewing anatomy. 2D slices of brains, but as we all know, the brain is a three-dimensional object. So what they're able to do is they take slices at different positions, and through understanding the different axes that we're taking pictures on, they can kind of figure out what the brain looks like. But a human doesn't look like this. No part of the human body is a slice in black and white. It looks a lot closer to this. And I didn't want to put a real brain up there, so this is just candy. But we're visualizing something that looks a lot more like this with this. So are you comfortable with a surgeon operating on your brain if this is all they've been able to prepare? And there's a problem somewhere in the 3D volume of your head, and they're looking at this 2D slice. This is an X-ray, by the way. And later, more advanced surgeons will use MRI or CT scans like this, where you're able to actually see slices. And there have been attempts at taking these slices and rebuilding them into a three-dimensional volume. But this goes back into what I was saying earlier. What use is viewing this in 3D in a three-dimensional volume if it still ends up on a 2D screen? Your brain is still doing all the work and understanding exactly how this image, which is a real patient, translates to the real patient that the surgeon is about to operate on. So this is my solution. And as you can see, the surgeon is actually viewing a reconstructed brain in the operating room. There's no movie magic happening here. This is all real time, the surgeon's view. And the surgeon's actually able to look inside the brain in an intuitive 3D way. So they're no longer constrained by having to understand the 2D grayscale images and then maybe opening up the patient and seeing where they need to operate. Instead, they can understand the patient. They can have the patient wide open before they ever have to operate. This can lead to a greater understanding of the case that they're about to perform. It can lead to faster operations. It can lead to less invasive operations. As the surgeon already knows where to target, they can make a smaller incision and be more direct in what they have to do. And hopefully, it will help people recover faster because they're having shorter operations and less invasive surgeries. And so in the operating room is not the only use case for this. We're seeing a lot of success in patient consultation. So what we were finding is that a lot of patients were just terrified whenever they had an operation incoming, because there's a problem somewhere and they don't really understand the human body, and the surgeon would show them images that look like this, as you can see on the computer screen, and the patient wouldn't really understand. But if we can put a doctor and a patient in the same headset and have them view their anatomy in an open environment with actual 3D reconstructions, maybe a patient will feel more comfortable about getting a life-saving operation. So they could view it like this instead of like this. And here's the brain again. So what they'd be able to do is understand. She's actually looking at an aneurysm brain problem in the skull base, and she was actually preparing for a real case with this brain, and hopefully was able to move a bit faster. So if you want to know more about this, this is our website. But kind of moving away from my own project, I want to address the creators in the room, because we are global creators. That's the name of the conference, right? And I want to urge people in this room that with the great power that we have, there is great responsibility that we must follow. Because it's going to be us that decides the fate of this technology, right? So this is from the 1990s. As you can see, it's this clunky toy in VR. This is, you know, a lot of criticisms say that early technology is just for tech nerds, or it's clunky and it doesn't really have any use. And these things are all true of new technology. No one is arguing against that. But it's only true until it's not. So it's up to us to ask the difficult questions here while we're building things. What do we want to see society use someday? How do we want to impact society when we're building this new technology? We have to ask difficult questions like, what happens when screens are ubiquitous? If everyone is wearing a headset that's able to bring computing into the real world, what happens when we can be on a dinner date and be watching a movie or playing a game or looking at someone else's WeChats? We have to ask, because it's up to us to build it how we want. What happens when children who have this technology, as we previously mentioned, they understand it as part of their communication development? So what happens when a child that has more money is able to communicate more effectively in the modern world than one who cannot afford a headset, or a child who does not have money? There could be a significant divide amongst children who aren't able to bridge that gap. And what happens when advertisers have complete control of our field of view? What happens when you could look at a glass of water and across your entire field of view it will say drink soda? Or you look at your newborn baby and you see advertisements for diapers. It's up to us to decide. It's up to us to build it in a way that will positively affect society. This technology is coming. It's not far away. I've used it. We're actually going to be giving demos of it over by the VR booths later. And so it's a question we really have to be addressing now of what do we want the future to look like? Because there's a lot of potential for this tech to be used poorly. And as we're interacting with technology in this new 3D space, we should hopefully want to allow our users to have an elegant way to use the computers that they already use in a completely new way. So in closing, I'll ask, what will you create? Thank you.